All right, so now let's look at what we call the zinc blend. So this is the second example in the previous quiz question. And so the zinc blend structure is, again, FCC configuration of the anions. Um, and then the packing, though, is different than what we saw with sodium chloride. So here, the tetrahedral sites are filled, and only half of them do so. Um, so this is also based on an FCC arrangement. Therefore, the Brave lattice is FCC. Um, but because we see that not all the tetrahedral sites are filled, we have 4 of them, but there's actually 8 if we go back to that schematic. So this is actually a fairly open structure. The atomic packing factor is about 0.41, and so it's a pretty open structure compared to others. Again, it's not close packed anymore because these cations open up that structure. And so this is a fairly open structure, like I said. This material, or materials with this structure, um, tend to have tend to be semiconductors, and that's due to the covalent bonding. So remember, tetrahedron, we talked about that in the propensity for covalency. So anytime you see that, leads you to believe that there's probably some covalency, and covalency also indicates semiconductors. And so this is a lot of semiconductors form into this structure. Another thing that we'll see in the or sorry, let me go ahead and get to the polyhedra sharing. So we see the tetrahedron here for the cation coordination, and so if we draw those out, we see that they're sharing the vertices or vertex, and so again that keeps it very far apart. The cations very far apart from one another. So we have corner or vertex sharing in this case. Some examples of this structure are gallium arsenide and also beta silicon carbide. And also zinc blend is the mineral name for zinc sulfide. And so that's where it gets its name, but it doesn't have to be zinc sulfide to have the zinc blend structure. So that's an important distinction to make. The other point I wanted to make here is that, so this might look familiar as a structure. So like, let's say if everything is equivalent, so instead of cations, anions, if everything was the same, then this is the diamond cubic structure. So they're, in that way, they are the same. And so that's an important kind of connection to make, because also carbon has a propensity for covalency as well. And so that kind of ties these two structures together. All right, so in this same section, I want to also talk about the Wurtzite structure, because Wurtzite and zinc blende are really related. In fact, a lot of the materials that form into the zinc blende structure that you can see here, that we talked about just now, also have this structure. So they end up being polymorphs. So at a certain pressure or temperature, they may change from one structure to another. So zinc sulfide can also form into Wurtzite, as well as zinc oxide, silicon carbide, and zinc telluride. So there's a lot of similarities between these structures. The main difference with Wurtzite is the fact that we have the HCP packing. So here you see that the white anions are that HCP configuration, and then we have filling of the tetrahedral sites. Oh, sorry, it's mixed up there. So we have, in this case, the white is the cation, and they've drawn it slightly different. But the yellow are the anion, and you see they're still filling the tetrahedral site, and in this case it's half filled. So we have, instead of FCC for zinc blende, we have HCP packing of the anions, and then we have the cations in half of the tetrahedral sites available. So these are two very similar structures in these cases. The coordination of both ions are both 4 in this case, and we have a similar kind of AB type of stacking of the the tetrahedral coordination that we see here. So if we look at the tetrahedron and we look at the sharing, we also see it can be kind of hard to see on some of these structures, like I said, but if we look at these, we actually have corner sharing. So this is just kind of showing it in a different way, but we have corner sharing as well on this. So this and Zinc Blende, I put them together because they're very similar. They have the same materials in a lot of cases, but the main difference is either FCC or HCP. And again, some of the examples are these semiconductors, the covalent materials, aluminum nitride, beryllium oxide, zinc sulfide, gallium nitride. So a lot of covalent type materials.